Hello, everybody, and welcome back to Scientific Terminology. Today, we're going to be talking about nuclear energy, and my little quote for that is when life gives you atoms, split them. And that's kind of how nuclear energy works, which we're going to get to in a little bit. But we're going to be talking about nuclear energy because was our first attempt at clean energy after we learned just how destructive coal and oil could be when manufacturing our energy. So let's get started. So what exactly is nuclear energy? Slide back over here real quick. Come back over. There. Oh, come on. There we go. Stop that. There we go. Okay. So what is nuclear energy? Well, nuclear energy is the energy released from splitting an atom. And the breaking of these incredibly strong bonds in atomic nuclei release a highly immense amount of energy. And we're able to harness that energy by controlling it in a sustained reaction, and it can provide energy without direct air pollution for a pretty long time, as long as we have the nuclear fuel to keep the reaction going. So how do we do that? Well, nuclear energy is produced using a controlled nuclear reaction, like I said. We fill rods with fuel, which is usually uranium, and we control that reaction with control rods, which makes it so that the reaction does not chain out of our control. The heat that escapes from these fuel rods heats up water, which then becomes steam, and then that steam rises through a turbine, which generates the useful energy that we use in our day-to-day lives. Here's a picture of how that works. So here we have the reactor with the reaction going on. The control rods are in there stopping it from being too much. It heats up some water, generates some steam. Steam goes through here, spins the turbine. The water condenses back in, goes back into the system, and it goes over and over again. The generator sends the electricity out, and we have a big reservoir of water nearby to cool off the condenser here and keep everything not too hot. Right? We don't want it to get too hot, nor do we want the control rods to get taken out, because that would allow the reaction to continue over time, and that would allow a meltdown, which is bad, in case you were wondering. So nuclear energy output, here are some statistics that you can find on the internet. Roughly 20% of Americans' energy come from nuclear energy. I grew up in Illinois, and there's over 20 nuclear power plants in that state. They give off lots of different types of energy. There are about 55 nuclear power plants, housing 94 nuclear reactors in 28 states. Each nuclear plant, on average, produces about a gigawatt of power, and that's equivalent to 3 million solar panels or 431 turbines. So it does produce a lot of energy, which is awesome, right? It generates the energy that we kind of consume, right? We consume a lot of energy in this country, and nuclear energy does not have the same kind of carbon footprint that coal and oil does. Now, unfortunately, we've started to realize that there are some drawbacks to nuclear energy. And that's that the fuel rods, once they're all done being used, have to be stored in a secure location until they're no longer radioactive. And that can take thousands of years for them to no longer be radioactive. And that's kind of an issue. We don't really know where we're going to store these things, where it's safe. And so the entire time these rods are cooling off, they're emitting radioactivity. They can contaminate water, crops, people, animals, all sorts of different things. So they need to be placed somewhere where that radioactivity cannot escape, which is a problem for us. We don't exactly know where that is. There have been some proposed solutions to this problem. One of them is to just bury all of this waste in a secure cement bunker somewhere in a mountain, which is great, except a lot of people really want a secure bunker full of radioactive waste near their homes. So finding a mountain that is kind of in a place that people are willing to accept this issue has been difficult. Another option is just to launch it all into space and make it somebody else's problem, which isn't really super great. And then the other thing is that we can store this waste underwater, but it's only for a limited amount of time. So there's ways to store it underwater safely, but it doesn't last forever. So that as long as it takes for it to become no longer radioactive. So that's an issue as well. So where is nuclear power used in the world? Well, as you can see, it's used a lot of different places. The most prevalent place is in France, where you can see they are the darkest green. That means they use the most nuclear energy. But it's also used elsewhere, right? The United States, Canada, Sweden and Finland, Spain, England, parts of Eastern Europe, and then, of course, Russia. And there are other places that also use nuclear energy, like South Korea, and a couple other countries that aren't actually on this map, because they don't actually, like, they say they don't have it, but they do. So it's not official that they have it. Anyway, thank you so much for watching, learning about nuclear energy. It's been great coming back and providing some educational content for you guys again. Make sure you like and subscribe. Ring the bell so you know when my videos are coming out. And let me know in the comments if there's something you want me to talk about specifically, and then I can make sure I can make a video on it. You can learn the things you want to learn. So thank you so much, and we'll see you next time. Thanks.